Hello, everybody. People out there, I trust you are doing well. Yeah, it's your boy Joseph Malto, and I've come your way one more time with an educative content as usual, still in the journey of what R programming. I've got something good for you this time around. I want us to look into the basic R graphics. Okay, basic R graphics as part of your data exploration and that of descriptive analysis. You might want to have a visualization of your data. Take for instance, if you are working, you are doing a qualitative data type, okay, you might want to visualize your data. You might want to have some graphics as part of your work, just to beautify your work. So that's what I'll be taking you through this very moment. So stay tuned and follow. Again, as of the making of this video, the idea is you already have the basic introduction to the software, okay? And so if this is your first time watching my video or watching this video, I'll urge you to check out for my other videos that I've made where I've taken the time to introduce you to what the R software, the R software. So you want to quickly give a glance to that and then what, turn back and what, come join us, right? Proceeding with the R software or the R programming language, has gotten a number of visualizations that we can equally do, and I've listed a few of them, just five. These are not all, there are others. Again, it does not come in any um order. It does not come in any systematic order. This is not to say the first basic R graphic is plot, followed by lines, followed by scatter plot, followed by pie chart or bar chart. No, it does not come in any other format or any other what numbering. Okay, good. So let's start with the first on the list. We'll be looking into plots, lines, scatter plots, pie chart, and other of what? Bar. And if there is more time, you look into histogram and other visualization as well. Okay, good. Now, in the previous video that I've made, we've come across function. We know what a function is. A function is basically anything that takes in an input, and then that input goes through a particular process, and then finally an outcome is being what generated for us. For instance, when I say 5, when I say 5 plus 9 here, the number 5 and the number 9 are the inputs. Okay, so these two inputs are going to go through a process that we call what the additive process or the addition process. Right, so having gone through this process, then finally it will give us what, an outcome. Right, so let's run this code. To run a code in the R, is you're going to hold on the control key. Going to hold on the control key, and then you press enter. As you can see, 5 plus 9 is indeed what, 14. Right, so the answer is being displayed for us in the console. In the console. Good. That's just by the way. That's just by the way. And so to have a plot, okay, as our graphic, you are going to need a particular function that we call the plot function. You're going to need a particular function that we call what? The plot function. Then in the plot function, inside, you're going to specify your various what, arguments or your various inputs, right? Some field of studies use the word parameter. And so I might be using the term input, argument, parameter. Look, it's basically the same thing. Okay, the difference is not that big. The difference is not anything to bother ourselves much with, right? So for the purpose of this video, when I use the term input, argument, parameter, that let's take it that I'm referring to what, the same thing for now, right? Good. And so you're going to have the function, the plot function. This is the plot function, right? So this function is going to take what, some inputs. Okay, so inside the round bracket, or we call the parenthesis, that's what I'm going to specify my arguments, right? I'm going to specify the various item, the various number that I want to plot. Let's say I want to plot 3 by 5. This is what I want to plot. So when I execute this code, it will give me this simple graphic or this basic graphic. But before I run this code, let me take the time and explain some concepts here, right? Now, let me erase this. You recall in our secondary level and junior high school level, we used to do there's a subject called core math, yeah, core math, where let's say they will give you, let's say A, and then they'll say A is probably 2 and 4, then maybe they'll give you another where let's say 5 and that of 6. And then we will be asked to plot this on the Cartesian plane, right? So to plot this on the Cartesian plane, or we refers to as the XY axis, all I need to know is that with A, the first item here, that is 2, corresponds to what the X axis, right? And then the 4 here corresponds to what the Y axis. That's what you need to recall. And secondly, when you come to the pair for B, the number 6 corresponds to what? The x-axis. The number 5 corresponds to what? The y-axis. Now, let's go back to the A again. A is what? 2, 4. Meaning, on the x-axis, and again, the x-axis is just what? The horizontal bar or the horizontal line. That's the x-axis. Then the y-axis is what? The vertical line. The vertical line is what? The y-axis. The horizontal is what? The x-axis, right? So here, we are going to locate the number 2 on the x-axis. And again, we locate the number 4 on the y-axis. Now, where they intersect, right? Where the x and y axis intersect, you put what? A dot there. That is basically what a plot is. Basically, that's what a plot is, right? And again, in the case of B, I'm going to locate 6 on the x-axis and locate the number 5 on what? The y-axis. Okay, then you plot, right? So I'm going to, I presume we've not matured yet. And so you're going to have a simple plotting of the x-axis against the y-axis. And then we have what? A multiple plotting of what? The x-axis as against what? The y-axis, right? But before we do that, let me give you the syntax for what? Plot. The syntax for plot. This is the syntax. So the syntax is, we have the plot function. We have the plot function. Then inside the plot function, like I said earlier on, you specify what your argument. So probably A by, let me just say X and Y. X comma Y. X comma Y. So this becomes the basic syntax for what? Having a plot or having the plot visualization. Again, there are more input that we can pass or that we can add to the plot function. A typical one is we have a particular parameter that we call the type, T-Y-P-E. Okay, so type is assigned into quotes P. But you see, let me pass a comment here. We can ignore the parameter type equals, or sorry, type is assigned, quote, we can ignore this and it will equally work. You see, by default, the software has been designed to understand this. So if I do not pass type to read in the plot function, the software assumes it to be what? P automatically. When we get to the case of the line, we just change the type from P to what? L. Okay, right. So having said that, I think this is a good place for us to get started now. This is a good place for us to get started now. So let's take an example. Let's take an example. Let's say we want to plot the line 2 against 4. Sorry, we want to plot the number 2 as against the number what? 4. So to do that, the syntax is what? Use the plot function. So plot, let me have the plot function. Then inside, I want to plot 2 against what? 4. Right, so this is a simple plotting, okay, of the x-axis against that of what? The y-axis, as simple as that. So we want to plot the number 2 on the x-axis as against the number what? 4 on the y-axis. And so with this, all that we need to do now is what? Execute this code or spill this code. So to run this code, you can either use the run button here and it will execute the code for us. So let's do that. Let's do that. So here we are. Here we are. Now check the plot windows in your software. You see, this is the y-axis where I'm hovering the cursor over. That's the y-axis. And then here is what we call what? The x-axis, as I explained earlier on. And so we said we want to plot 2 by 4. So it means we are going to have the number 2 on the x-axis here. This is 2 on the x-axis. And then the number 4 on the y-axis. Again, technically, because we do not specify the calibration, the software will just take a default numbering for us, right? The software will just take a default numbering or calibration for us. Good. So we have 2 on the x-axis. The next thing to do is to locate the number 4 on the y-axis. As you can see, the 2 is written down here for us. 4 is written here for us. This is the y-axis. So you agree with me that 4 should probably be between 3.5 and what? 4.5, right? So in between 3.5 and 4.5, probably I'm going to have the 4, right? So now, having located the 2 on the x-axis and then the 4 on the y-axis, the next thing to do is what? Draw a line, not a line as in drawing per se, but the next thing is that wherever they intersect or they meet, we put a dot there. This is what a plot is. So here I've plotted 2 against 4. Let's do similar one. Let's do a similar one. Let's plot, maybe let's plot 1 against, no, let me say 5 against 6. And let's add the type parameter to it. Though I said we can ignore it, but it will equally give us the same outcome, right? So let's run. Go enter. Here we are. This is 5 on the x-axis. This is what? 6 on the y-axis. Where they intercept, I have my plotting there. Where they intercept becomes what? The place that I'm going to have the point or the plot. Yeah. Okay. But you see, what we've done so far is just what? Single plotting. It's not always the case that you might be doing what? Single plotting. Right? At a point, you might be doing multiple plotting. In fact, in real life sense or scenario, we do what? Multiple plotting. Right now, let's look at the case of what? Multiple plotting, how to go about it. Let's say maybe A is assigned, let's say 1, 3, 5, and then probably 7. And then B, again, A and B are variables. B is assigned. B is assigned. Okay, because we have multiple items, let's use the C function. B is assigned 2, 4, 6, 8. Okay, now I want to plot these two guys. I want to plot 1, 3, 5, 7, and what? 2, 4, 6, 8. How do I go about doing it? There are several ways that we can do it. One of the ways is you can, first of all, as I'm doing, assign them to the variable A and B, and then what? Execute it first. So I've run it. Now next, I apply the plot on it. So now plot into bracket A, comma, B, where A is what? 135, B is what? 2468. Now I'm going to run it. Here we are. So we have what? 1 on the x-axis, 2 on the y-axis. Where they meet, I'll put a point there or a dot there. Or it could be, we can refer to it as period, no problem. Again, I have what? 3 on the x-axis, 4 on the y-axis. Where they intercept, I put a dot there. I have 5 on the x-axis, 6 on the y-axis. Where they intersect, I put a dot there. And then finally, 7 against what? 8. So here I've had what? Multiple of what? Points. Multiple of what? Points. Okay, this is basically what a scatter plot looks like. This is basically what a scatter plot equally what it looks like. One would say um it's a plot that is scattered, right? Scatter plot is a plot that is scattered. Yeah, that's funny to say. Now let's look at some alternative ways of doing the same thing that we did. Okay, maybe I have the plot function. Now, instead of typing A and B, I'll just cut this or I'll just copy this, come and paste it here inside, have the comma. Then I'll copy this, come and paste it here. Then I'll execute this code. So however way you want to do it is up to you, the programmer, or up to you, the one doing the work. So one can decide to first of all assign the various coordinates to a variable, and then from there use the variable name as what the inputs. Okay, you might equally want to do it this way, though I wouldn't personally I wouldn't prefer this in the sense that coding this way at a point can make your line of code very lengthy. The example I use is just a simple example, so it might not look that lengthy, but as we progress, we come across extensive lines of code where we can have what a very lengthy code on just one line of code. When I say one line of code, this is what I'm referring to. So here is line 21. So everything on the entire line is what we call what a line of code. This line 14 of my screen, everything that's what refers to what a line of code. Okay, so either this line 19 or that of line 21, it will give you the same answer. So let me just say alternative way, alternative, right? To give you the same response, let me intentionally change some of the values. The idea is still the same. The idea is still the same. So here it will locate 1 on the x-axis and then locate 5 on what the y-axis where they meet or where it intersects. You're going to have the point there. Next, to locate the number 6 on the x-axis and then 4 on what the y-axis where they intersect. We have the point plotted there. Right, in that order, all the way to the very last one. Where is the last one? The last one is what? 3 against what? 6. So let's run this code. Let's run this code. Control, enter. So here we are. One against 5. 1 against 5. This is the point. 6 against 4. 6 by 4. This is the point. 5 by 3. Sorry, 5 against 3. Yeah, this is 5 and then 3. And the last one, 3 against 6. 3 against 6. So this is an example of what we call what? A scatter plot, right? So here we have what? Multiple plots. Okay, so multiple plots. This is multiple plotting of x values against y values. So multiple plotting of what? X values against what? Y values. Yeah, that's just by the way. Now let's look at this. Let's look at this briefly. Let's look at this briefly. Let's look at this briefly. Let's have plot. Let's plot 1, 2, 3, 4, 5. What am I trying to say? This is what I'm trying to say. This is what I want us. This is what I'm trying to say. Let's say variable v is assigned 1, 2, 3, 4, 5. Let's have another variable. Another variable r is assigned 1, 2, 3, 4, 5. Yeah. So this is what I want us to do. If we're given two variables v and r, okay, and then v is what? 1, 2, 3, 4, 5. Again, r is what? 1, 2, 3, 4, 5. And we want to plot this. Take note, the idea is still the same. So first of all, locate one on the x-axis, locate one on the y-axis. Where they meet, it will what? Have the point there. Locate 2 on the x-axis, 2 on the y-axis, 3 on the x-axis, 3 on the y-axis, all the way to what? 5 on the x-axis and what? 5 on the y-axis. As simple as that. So let's plot it and have a look at it. Then I will bring the idea of what? The sequence. Okay, so now let's run this code now. Plot v by r. Let me increase my not got it to line yet. Now let's run this code, line 25. Now what do we see? You see 1 is to 1 or 1 on 1, 2 on 2, 3 on 3, 4 on 4, 5 on 5. So whenever you want to have a plotting of this nature, it is advisable to use the sequence plotting. It's advisable to use the sequence plot. What do I mean by sequence plotting? Let's have a look at how the sequence looks like. Again, we want to check my previous video to have a feel of it. Okay. So whenever you want to plot a number as against itself, okay, in that case, you can use the sequence, what we call the is to. Then you specify the starting toward the ending. You have the starting toward the ending. So let me just run the code 1 is to 10. Again, take note here, I'm not plotting. I'm just executing the code 1 is to 10. Now let's run. Check your console. It spells out what? The range of numbers from 1 to 10 with what? An increasing order of what? 1. Right? Let's do that of 1 is to 5. 1 is to 5. Again, 1, 2, 3, 4, and what? 5. 1, 2, 3, 4, and what? 5. So in the case of V and R, to plot this, I can equally do it this way. I have the plot function. I have 1 is to 10. and then it will get the work done for us. That's a short way of doing it. So I have plot 1:5 or 1:10, whatever way you want it. So this is a short way, a short way. Then probably here, this is the long method or the long way, right? Again, this is in situations where your X values and Y values are the same. Take note. This is a situation where your X values and what Y values are the same. Now let's run this code. Let me increase my plot region. Then run the code now. As you can see. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Check my graphic. 7, 7, 8, 8, 9, 9, 10, 10. Right. Isn't that interesting? Of course, it is interesting. That is very, very interesting. Good. Let's move a step further. Let's move a step further. Let's move a step further. Now, you see, with this graphic, even though we've been able to generate the outcome, the graphics, you see, it might not necessarily make sense. What am I trying to say? When you give your work or graphic to someone, that person should be able to draw meaning out of it, even when you are not there to explain it to the person. What am I trying to say? Should I send you my work? You should be able to draw meaning from the graphics, even at my absence. Right. So now that you've been able to know the syntax to have a plot, it is also ideal to make it more meaningful. How? By adding some stuff or adding more flesh to it, kind of. Okay, so here we can label the part of it. We can add axis. We can add whatever we want to do. Mind you, the syntax that I give you here is just what the basic. You require even say you can even ignore the type, right? So as we progress, we'll be adding more arguments to what the plot function. We are going to be what adding more arguments to what the plot function. Follow me carefully, right? Now let's start with labeling our plot. Okay, so let me give a heading. Let's say graph labeling, right? You want to label our graphic. You want to label our graphic, right? So let's go. Let's go. Let's go. We have the plot. Let's use the short way. Let's use the short way. Let's say A is a sign. Let me just copy this code, okay? Let me just copy this code and come and paste it here. So 1, 3, 5, 7. Let me add 9 to it. Then let me add 10 to it. Good. Now let's rerun it. Let's rerun it. Now let's plot it. Let's plot it. A, comma, B. Let's run. Let's run. Yeah, this is our outcome. And we are saying we want to what? Add more stuff to this diagram that we have. Right? You see, we can name the x-axis, we can name the y-axis, we can name the heading. By default, when you fail to name the axis, it will pick the variable name for you. So in the case of x-axis, the variable a is being used by the software, meaning when we fail to specify our axis name, the software will by default would specify one for us. It could either be the in this case, it's using the variable name because we use variable. If I had done it direct, I would have used the various number for it, right? So to make our work more beautiful and nice, we can just do that to our work. So let's copy and paste the same code again. right? But this time around, we want to add more item to it. We want to add more item to it. We want to add the x-axis, the y-axis, the title to it, just to make it what? More beautiful. Just to make it what? More beautiful, right? So again, I have A, comma B. Let's add the x-axis. So the argument for that is the x lab. The parameter x lab is assigned quote quote. So what should be the name? Let's just say x axis, right? X axis. X axis. Now let's run. Let's run it. Have you seen? We've been able to what specify our x axis now, right? But you see that of the y still remains b. Why? Because we didn't specify it. Right, to specify the y-axis, we just add the parameter y lab to our code. Right, so we have y lab is assigned quote unquote y-axis. Again, it could be any word of your choice, depending on what you are doing. At a point, we might not specify x-axis and y-axis. We might specify it conceptual, right? Good. So let's run this code again. So at this point, the y-axis is being what? Labeled for us. How about the title? How about the title? How about the title? This is where one can easily transition from one software to the other. In the case of Jupyter or Python, the X lab would have been X label, right? The Y lab would have been Y label. And then title is title in the case of what? Python. But then in the case of R, we don't use title. We use what we call a parameter we call main, M-A-I-N. M-A-I-N. So, yeah, quote, quote. Now let's specify the name or the title we want to give to our graph. Let's specify the title that we want to give to our graph. Probably you can say my first basic R graphic. My first basic R graph. As simple as that. Now let's run the code. Now you see, if you should give this code, this work or outcome to someone, at least it make meaning. It makes sense, right? If you label your x-axis, if you label your y-axis, if you label what the title. Again, the x-axis and the y-axis, you can equally scrutinize it again further. Why are we scrutinizing it? Because if you just say x-axis, you've said nothing. You've said nothing, right? Probably you can say the x-axis is just maybe even numbers. The y-axis what the x-axis even numbers. The y-axis also what odd numbers, right? As you can see, 1, 3, 5, 7. Then what 2, 4, 6, 8. So 1, 3, 5, 7 is what odd numbers in our order. And then 2, 4, 6, 8, 10 is what even numbers. So we could have equally said, let me copy this entire code, Control C, and then paste it, Control V. Let's change the name x-axis to, let's change the x-axis to odd numbers. Odd numbers, right? And let's change the y-axis to what? Even numbers. Even numbers. We want to make our labeling conceptual, or what we call, it should be in context, or contextual. So even numbers. Now let's execute this code. Execute with Control Enter. So here we are, odd numbers, even numbers. So if your professor gets to receive of this work of yours, he or she can tell that, oh, so the x-axis are actually what? Odd numbers. That of the y-axis is what? Even numbers. And then, oh, your first basic paragraph. Oh, okay, wonderful. So at least at this point, we've done something better. We've improved a little bit just having the diagram without we not specifying the axis and then the title. Is that okay? Good. So this is how far we've come with regards to plot. That's not all. There is more to be done. Honestly, there is more to be done. But I believe we've done good so far. We've done good so far. But let's see what we can do to it again. Apart from the axis, the x-axis, the y-axis, the title. Is that all? No, 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 no. There is more to it. Right now, let's look at graph appearance. Let's look at how to change some of the appearances in our graph. How do we do that? Probably you might want to specify a color, a color of our choice. You might want to specify the shape or what. You might want to specify the size. Okay. Whatever be the case, you are at liberty to do so. But we will take it one at a time. We will start with what specifying the color, the shape, and what the size in that order. So let me give a heading that I'll call let's just say graph appearance. Kind of trying to change the overall appearance of what our graph. Is that okay? Yeah. So let's have plot. Again, let's still use this same diagram just to save time. I'm saying you can specify the color, the shape, and what that of what the size. Now let's start with what color. Let's start with what? Specifying the color. Is that okay? Now, again, to specify the color, you just need to what? Add the color argument to your code. Just need to what? Add the color arguments to your code. So the color argument is spelled C-O-L. C-O-L for color. Then bring your assignment operator, quote, quote, to specify the color of your choice. Right? Specify the color of your choice. So let's say green. And let's run. Again, it doesn't mean I cannot add the X label, the Y label to, I sure can. Okay, I sure can. Yeah. So let's run. So as you can see, the points or the plot changes to what? The color that we specified it to. Someone can specify blue or red. And it does just that for us. So at this point, what we've learned is that if you want to specify the color of the point, what you need to remember is what? The color parameter. The color parameter. COL parameter. Right? Recall in this case, if you want to specify the x-axis, what you need to recall is what? The x-lab. X-lab. If you want to change the y-axis, what you need to recall is what? Y-lab. Y-lab. Having said this, I need to say this to you. Again, we don't memorize code. In any programming language, we don't memorize code. However, we learn code, right? We learn code. The fact that we don't memorize code does not mean we don't learn code. Of course, we do learn code. Is that okay? And with this script, at any point in time, you can what? Refer to it. You can make reference or inference to it. Okay. All that matters is grabbing the understanding, what the concept. Then from there, you are good to go. Then from there, you are good to go. So for the color, we have the COL, and that will do it for you, right? How about specifying what if you want to specify the shape? What parameter will help us do that, right? To specify the shape of the point, we have the PCH parameter. PCH parameter. PCH parameter. PCH parameter. PCH parameter. That's all that I need to remember. So we have the plot. And as a matter of fact, let me add more notes here. There are there are 26 there are 26 point shapes. There are 26 point shapes, right? So, and it's numbering from 0 to 25. Right? There are 26 point shapes numbering from what? 0 to 25. As simple as that. Numbering from 0 to 25. Okay. So the default so let's plot what we're plotting earlier on, A, comma B. So here you want to work with what? The shape, right? So I told you what you need to remember is what? The PCH. PCH. Okay, then you specify the number, whether 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What it does is, have you seen this circle? As in the intersection is represented with, let's say, a dot or a circle-like manner. Okay, but we want to change it from this state to probably a different state. Maybe we want to have a triangle, we want to have a square, we want to have a kite shape, we want to have a rectangle. In that order, is that okay? That's what we mean by what? The shape of the point. The shape of the point, right? So let's specify 0 and let's run the code. You see what happened? That's changed from what? The default state. The default state is 1. Let me change the 0 to 1 and let's run. Like I told you, the default state is what? 1. So let's change the 1 to 2. Let's run. So you see, by changing to 2, it gives me what? A rectangle, sorry, a triangle. Right. So let's change it to 20. So there is what 20 looks like. It's also a dot, but this time around, it has been shaded or deepened. Yeah, let me just say shaded. Compare that to the default one. Right? And so by default, the point shape is what? 1. And so in that case, it wouldn't even make sense to even say PCH is assigned 1 because that's the default state. So if that is the case, why then do you go ahead specifying that? Unless you want something else, that is where you might want to specify the point change. So, okay, but what you need to remember is that there are 26 of them, numbering from 1 to 0 to what? 25. Let's try the last one, S25, and let's see how it looks like. So here we are. Here we are. Does it about what? Point shape. Does it about what? point shape. Is that okay? Now let's do let's try to visualize all the various point shapes that we have. Like I said, there are 26 of them. Let's see, let's see how to um picture them out. Okay, let's see how we can picture them out. Then after I'm done with all of what I'm teaching, then we will have a code where we will make all of them together. Is that okay? Let's have the plot function again. Let's have the plot function. What do we want to plot? We want to plot A, B. If you like, you can just come and copy this, paste it inside. If you don't want to have the A and B, like I said, to give you the same results. Whether I use the variable name or the values like this to give you the same result. So from here, PCH, that's what we are working on at the moment. So there are 26 of them. Let's use the sequence or what we call the index to make it easier for us. 1 is to 0 is to 25. And here, let's run it now. Oh, I did 0 minus 25. I thought I put is 2. Yeah. So now let's run the code. Take note, it is 0 is to 25, not 0 minus 25. 0 minus 25 is what? Negative 25. Let's run the code now. Coming. Yeah. So you see, with this code, the idea was I was trying to project all the 26 point shape that we have. But guess what is happening here? You see, here we have how many entries? 1, 2, 3, 4, 5. We have only 5 entries, so it cannot display all the 26 for us. It can only display only 5. So 1, 2, 3, 4, 5. So if you want to see the 26, then in that case, must what specify 26 individual X values and what Y values. Let's use the index plot. 1 is to 26. So here it will give us what numbers from what 1 to 26. Do you see it? Right, 1 to what 26. Then from here I can add the PCH and specify what 0 to 25, where each will change. So this one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to what 25. So it will be changing as at the various position. Okay. Now let's go back to the code, line 47 of my screen. Now we can safely bring the PCH again, bring the assignment operator and do 0 is to 25. And then let's run it now. So at this point, it will project all the point shapes for us. To project all the point shapes for us. As you can see, there is for 0. 0 is square, right? 0 is the square or the quadrilateral. 1 is the circle. This is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way to what? The 25. Okay, the 25. So here we are trying to we are displaying all the point shapes. What we are doing is for displaying all the point shapes in the R software. I like passing comments in the sense that, and I'll equally want you to do same, because at a later time when you pick your script, I mean, it tells you what you are doing. So, okay, it gives a narration to what you are doing. So be in the habit of what? Using comments. To have a comment, we use what? The hashtag. Is that okay? Good. So again, what if I want the point shift to be in a horizontal format? So you see, in this case, it's not really in a horizontal format, right? It kind of looks like a step case. And so if you want it to be in a horizontal format, in that case, you're going to use the rep function in addition to this. So just copy this code. So, and then let's edit it. I just copied and pasted. Let's edit it. Let's have the REP function, right? REP function. So let's specify 1 is to 26. So display, this will displays the point shape vertically. So here it displays the point shape displays a point shape diagonally. Right. So if you want it to be displayed, if you want it to be displayed or not vertically, sorry, horizontally. Yeah. You want to display it what? Horizontal. So it to be in a line, kind of. So now let's run this code. Now having done that, let's run it now. So for the ref function, this is how it looks like. As you can see, it has displayed them for us what? Horizontally, horizontally, horizontally. So this is it about what? Point shape. This is about what? Specifying the point shape. Let's do the final thing. That's what specifying the line, sorry, the size of it. Specifying the size of it. Specifying the size of the plot. Or another word for the plot is, you can say dot. Right, so we've looked at specifying the shape of the point of the dot. We've looked at specifying the color of the point. Now, finally, I want to look at what? The shape, sorry, the size of the point. The size of the point. Let me put a hashtag over there. Specifying the size of what? The point, right? Again, here, all that I need to recall is that what? To specify the size, we are going to use what? The sec or the CEX parameter, right? You need the help of what? The CEX parameter, the CEX argument. So anything size has to be the what? CEX. The default CEX is what? 1. That's the default. So you can maximize it, you can minimize it. It's just up to you. But the default is what? 1, right? The default is what? 1, CEX. So again, let's go plot. Let's copy this code again. I'm copying the code on line 46 of my screen. Then I'll change the PCH change the PCH to CX. Also, yeah, then it's assigned. I told you the default is what? 1. This is the default. This is the default size of it. It's not that big. It's not that. It's just the default size of what? The point. Okay. So default CEX is 1 or 1.0 is the same as what? 1. Right. So how about we change it to 1.2 and then let's run. You see a change? Realize the size of the point has increased a bit because I changed it from what 1.0 to what 1.2. I told the default is what 1.0, right? Now let's change it to 1.5 and let's see what happens. Wow, it keeps increasing as what I increases the CX argument. Okay, let's try something strange. Let's do 2.5. Oh, see, as I increase the CX, the point also what increases in that manner. The point or the dot increases in what that manner. Let's try 4.5 and let's have a look at how the size will look like. Look so big. It looks so big, right? So let's have something less than 1. Let's have something less than 1. Let's say 0.75. 0.75 and let's run. So you see, it is smaller than the default of what? 1. It is what? Smaller than what? The default of what? 1. Is that okay? So that is it about what? Size. All you need to recall is what? For size, you need what? You need the CEX. You need the CEX. Okay, so now let's put all that we've learned so far. Let's put them all together as 1. Let's put them all together as 1. Okay, let's put them all together as 1. And that will be the last thing under. That will be the last thing under what? Point. That will be the last under point. So finalize. Finally. So as usual, let's copy this code and let's plot. This is what we did earlier on. I've had an error. Again, whenever you come across an error, don't freak out. It's a matter of you taking the time to read the error and what correcting it. Is that okay? Good. Control Enter. Whenever your console gets occupied, you can just clear it by doing Control L. Hold the Control key plus L. It will clear your console for you. So Control plus L will clear the console for you. Right. Now let's run this code. Control Enter. So we have what? 1 is to 2, 3 is to 4, 5, 5 and 6, 7 and 8, 9, what? 10. Check my plot window. Okay. This is the basic graph that we've been doing all along. And then we said that of my plot function, copy this, then I come and paste it inside. Then I run. Yeah. Good. So this is just what basic. Okay, we want to add more items to our graph. So we are going to merge everything we've done today. We are going to merge we're going to add more arguments to it, not merge per se. We're going to add X lab or Y lab, the title. We specify a particular color. We specify the size. We specify the shape. And then we go ahead to also what? I think that's all that we did today, right? The labeling, then the appearance. Good. So I'm going to do all of this together. Okay. So from here, let's go. Let's say X axis. The X axis, but is spelled as what? X lab or X label. Let's say let's find a name that will be contextual. X is 1, 3, 5, 7, 9. Y is 2, 4, 6, 8, 10. So let's say X lab is first 5, even numbers. Right. Let's specify Y lab. Y lab. And I'll be teaching you something here very, very important. Quote. Don't forget your quote. So first 5, even numbers. Have you seen the code gets very lengthy? It gets lengthy. Again, recall to separate one item from the other, we use what? A comma. So X starts from here to here. To have the Y, I brought what? A comma from here to here. To bring the X lab, I have to bring the comma. After specifying the X lab, to bring the Y lab, I need to bring what? A comma as well. After specifying that of the Y lab, to bring any other argument, I will need to specify what? A comma. So main, where the main is for the title, right? So let's say what do we suggest? Let's say even numbers against odd numbers. Even numbers versus odd numbers. You see the quotes get very lengthy. So first 5 even numbers. First, oh, I've done a mistake. Yeah. So again, the software, what you specify, it is what is going to project for you. I type the first 5. Okay, that's it. First 5 even numbers and what? First 5 odd numbers. So the Y lab, is odd numbers. Not even, yeah. Yeah, so first 5 odd numbers, and then first 5 even numbers. Let me teach you a simple or a better way that we can do this, because with just the X axis, the Y axis, the title, I mean, the code is very lengthy. How about when I begin to add the color, I begin to add the shape, I begin to add, realize it might become very lengthy. Not to say it will not work, it will work. Let's just continue. So let's add color, C-O-L. Don't forget the comma. So C-O-L is a sign. Let's agree on a color. Let's say green. Right. Then let's decide on the size. CEX. We want it to be a little bit bigger. Let's say 1.1.3. That's the size, right? What's next? What is next? The shape, PCH. The shape, PCH. Let's choose number 40. Then let's run the code now. But you see, this line of code is very lengthy and it doesn't really, this is not a good way of coding, right? So let's do the same thing alternatively. Alternative methods. Sorry. So let's have the plot function. Now let's walk inside the function and let's press enter. When you press enter, this is what it's going to do. It's going to bring the closing round bracket beneath or down. It's going to bring it down for you. Then in between the opening and the closing round bracket, you'll be able to type any other code of your choice. So let's hit the enter button as you see right here. Now let's copy just this one. And let's paste. Right. Now, if you want to add more items to it, you just remember to bring the comma. So let's add xlab again. Xlab. Let's say first 5 odd numbers, comma. Maybe if I bring the ylab, the code might become very lengthy. So I'm going to press enter to bring it down for me. You see? Then I continue with the code. Ylab. Ylab is what? First 5 even numbers. So I'm done specifying the ylab. The next thing is what? The title. Again, it can be in any other format. It's not to say xlab first, ylab followed by the title. No. Even at this point, I can start to bring the color, the point shape, even before the title. Doesn't matter, right? So the title. So let's say even numbers. Against odd numbers. So let's work outside the closing quote. Let's bring comma. Let's press enter to bring it down for us, right? Then let's add the additional item that we want to. At this point, if I run this, what I've specified will be projected for me. So do control enter and let's see. As you can see, right? So let's go back to it. As soon as, always remember to bring this comma. When you hit the enter button to bring it down, then you can continue the coding. So let's say color. Let's say red. Whether uppercase red or lowercase red, it doesn't change anything. It will still give you the same result, right? Though it is advisable to have it in the lowercase because Doing that, as soon as you tap the color, it will give you a highlight of it. Then probably you can tell that you like it or not. Okay. But whether you use uppercase R, lowercase r, it will not change the result. So that's for the color. The next thing you want to add is probably the shape. For shape, you all know that what is what? PCH. You specify the number. Like I said, it spans from 0 to 25. So let's choose 13. Let's bring size. CX. Let's specify what? What size should we specify? What size should we specify? We want to specify maybe 1.5 because I will not be adding any other arguments or any other input to the code. I don't have to bring a comma. I'll only bring comma if I want to add more items to it. So to run this code, wherever the cursor is, just hit the Control Enter or the Run button. Or if you like, you can highlight everything. If you are highlighting everything to run, ensure you do the highlight very well. Control. So as you can see, all that I've specified here has taken effect in the graph for me. So wonderful people, that is where we'll be ending the session on with regards to what? A plot. Right. So in my next video, I'll be continuing with that of what? The line. I'll be continuing with that of what? The line. And so you want to check it out as well. Thank you for your time. If this is your first time watching my video, I encourage you to like, share with your colleagues to equally benefit from it. This is an educational or educative content that is being shared. And so I will urge each and every one of us, if we find interest in it, why don't we share with what our colleagues? Why don't we share with what our colleagues? Thank you for staying tuned. Bye-bye. See you again.